All right, welcome to our last video on the Sustainable Product Platforms series. And today we're going to talk about knowledge economies and the changing possibilities for closed loop manufacturing. Possibilities that didn't exist when I originally did my research and work back in the early 2000s for my original book, Earth Inc., that I published with Harvard Business Press. Since that time, there have been a lot of advances, and especially around technology and new approaches to technological manufacturing that changes the game. But one of the fundamental elements, we talked about scale economies, which is spreading out a single design over multiple production runs. We also talked about scope economies, using a platform and using it to provide the production of a portfolio of different products. We haven't really talked that much yet about knowledge economies, and knowledge economies are very important because it's the process of learning, capturing that knowledge, and using that knowledge to then improve and enhance both production efficiency, quality, etc. Okay, knowledge economies depend on how well a company can capture useful information produced at different points in the value cycle, then use that information to drive constant improvements. Right? And as everything, there is a biological precedent for this. I mean, the biology, the genetics of life has this built-in system of capturing knowledge and information. You know, that's what happens. Survival information about what works, about what it takes to survive, say at the deep in the ocean versus what it takes to survive at the top of Mount Everest versus what it takes to survive in a rainforest. That information is encoded in the DNA. And that DNA is conserved, and whatever is expressed in various different ways. It allows life to innovate on that platform, but also capture and conserve the information about what it takes to survive. You've probably seen that human beings share 99% of our DNA with our closest evolutionary relatives like chimpanzees. I forget what exactly the number is, but we have a lot of banana DNA in us. So that information is conserved, and it's used and innovated and riffed upon over time. Okay, so that's because there is a closed loop nature to the production process. The closed loop nature provides a feedback loop. It provides constant information, and especially if you are not selling your product and forgetting it, but you're planning on getting it back, and you're maintaining contact and capturing data about the operation and use of it, there is a constant information flow that can be leveraged by your company. So, and this has really been enhanced now by the sort of the internetification of everything. I mean, there's the Internet of Things, the ability for us to put low-cost sensors and microprocessors that allow us to capture information at multiple points of a life cycle or continuously for a product on its performance, on what's happening, through these sensors, through cloud computing. All of this now has made the possibility of continuous real-time data capture a possibility, something that can be leveraged in terms of a value cycle, right? So where this becomes interesting is when this is actually then part of an integrated platform, where your company is integrated and controls multiple aspects, or at least has powerful partnerships that allow you to influence and transfer information through the system. One of the problems with open source systems is there are no incentives to share information, vital information between the different partners. Usually what you are doing is, if you are bidding, say, for waste on the market, you want to hold your cards, your information you have, so that the person you're bidding against doesn't know how much you're willing to spend or what you're able to do with it, right? So there's an incentive to have asymmetric information. Even in a partnership, though, sharing information across the boundaries of a partnership is very difficult. Trying to get materials manufacturers to tell you about the formulation of their product is very difficult. It requires usually either a blind third party that will do the analysis for you. You tell them what you're interested in, or it requires very complicated legal non-disclosure agreements, right? Because no one wants to tell you that. Now, that's one of the potential powers in a vertical integration, is that those barriers to that information sharing can be minimized. They don't go away. It's even within a single company. There's often, siloization of information and knowledge, and but at least the barriers can come down, right? So when you integrate these functions, you're generating knowledge at all of these points in the value cycle: product design, manufacturing, sales, service, etc. All of this then is providing data points that re-enhances and reinforces the different elements of the value cycle. All right. So early examples of this, we saw this with the Fuji Xerox Eco Manufacturing. When they started disassembling and remanufacturing these problems, they learned a lot about the wear and tear that these products go through in their life cycle. And in fact, they became so good they could run tests and be able to predict in advance when failure was likely to happen, or when replacement was going to be needed of components. So this provided all kinds of opportunities to improve the quality of service, the uptime and the operability of their products in their customers' offices. Also, it allowed them to provide design information back to the manufacturers of the original products, telling them, hey, this is where wear and tear occurs, and we can make some design improvements here so that these components will last longer and they will be more amenable to actually refabricating and refurbishing. All right. So all of that information, because it was within the single company, began to be shared. And normally when you're just selling your printer and forgetting about it, you lose all of that information, and that information doesn't become available. But when you become conscious of, oh my gosh, we are now that we are in ongoing touch with our customer, we can become systematic and figure out low-cost, effective ways to collect that information. This is even becoming much easier now by the fact that we can put these low-cost sensors and computing capacity for the Internet of Things. So all of this becomes open. And that there's the knowledge loop in your value cycle. The knowledge back feeds into and enhances then the production, the integration, and the performance of the overall value cycle. So Fuji's not the only one that discovered the power of this. IBM, BMW, all of them have these labs where they try to capture information about the use, the disassembly, the reassembly, the refurbishment, and use that information to enhance then the initial design, the production process, etc. So it feeds back in a closed informational loop. Right? Now, one of the other major innovations that is a real game changer is the rise of 3D printing. We've talked a little bit about 3D printing, but 3D printing actually has the potential to be a very powerful basis for a sustainable product platform. That's because there's a lot of reasons, and I will probably link a separate article down below this video if you want to delve into it. But fundamentally, what 3D printing does is it builds an infinite number of different shapes and forms and products additively from the bottom up, much the way nature does, using a single material, right? So this same material could be used to make a bunny rabbit, could be used to make a coffee cup, it could be used to make a sprocket or a gear for your bicycle, it could be used to make a cast, it could be used to make eyeglasses frames. The same material can be configured in multiple ways, which you can begin to see very clearly if you choose the appropriate material and you have a system to recover and recycle that, and recover that material, recycle it, refurbish it, and put it back into your 3D printer. You have the basis of a sustainable product platform very easily. Right? And we're already beginning to see how the knowledge economies can fit into this system exceptionally. All right. So Local Motors, we talked about before. Local Motors is the company that manufactures automobiles. most of them done through primarily through 3D printing, or 80% of the vehicle is 3D printed. It also uses, though, information systems very intensively as part of its program. It has a knowledge or information platform, a community of open source designers, and then its manufacturing process that it operates simultaneously. You know, it says here, better ideas, faster products, less cost. The platform allows the community designers to come up with designs. They call it co-creation, but they have open source competitions for people to come up with the design of the next vehicle, and a variety of engineers and other designers compete to do that. They work with local motors executives to ensure that what is being designed can actually be produced, and then they have their micro production facilities, which really are just these, you know, small 3D printing places with a small workshop where you can put your electric motor in, your tires and rims, and effectively build your car locally, right? So it opens up all kinds of things. But fundamentally, the information about the design of these is being captured in code. There are these files, much like you have a PowerPoint file or a Word file or a database. The three-dimensional design criteria is coded into, you know, basically a CAD design or something like that. So the information, much like DNA now, is being captured in this case in digital form and can be shared globally, right? And can be iterated on. This is truly where, you know, open source computing design comes from, and some of the benefits, you know, you think of the App Store and some of the other possibilities that come from having a common platform in the computing world. All of the different apps that can be run on your single phone, we're now moving to the possibility that can occur in the physical realm for physical objects. And so then just like the survival information is encoded in DNA, the design information for a huge variety of products can be coded, put into, you know, a platform like this. This is one of many design libraries, repositories of 3D designs. This one, the Thingiverse, that you could go in and basically search, find a design you like, and either send it to your own 3D printer or send it to a community 3D printer at your library or a print shop in town and actually fabricate what you want. This is going on now. This is not something in the future, and there's a variety of these, which, you know, begins to close the loop on the knowledge, the design, the key elements. What's going to be important here in order for this to succeed, for 3D printing to actually support a closed loop circular economy, is that the design criteria, the Biosphere rules, have to be built into the design criteria here, which means the materials we're using for 3D printing have to be selected carefully so they are amenable. They can be economically and engineeringly, in a way, viable for value cycling. Ultimately, we're going to have to move towards renewable energy, but that's not so bad because 3D printing actually uses electricity, and so it's already been demonstrated that you can run your 3D printer off your solar panels. You're going to need some kind of backside, a way to take your old 3D printed items and then break them down and turn them into new filament for your next production run. There are already examples of this, though. There are things called recycle bots that have been designed and demonstrated that will grind up these old prints and create new raw materials for the next production run. So the elements are here, and you know, we're a long way from 3D printing becoming the foundation of a closed loop economy, but all of the elements are there, and I'm of the belief, with appropriate design, with appropriate engineering effort, 3D printing can become the open source basis of a closed loop circular economy. Now, opens up lots and lots of questions. It opens up lots of opportunities for product designers, for manufacturers of 3D printers, etc. But it also opens up huge questions for alternative manufacturing, more traditional manufacturing. As this improves, almost anything theoretically can be produced